Hello, hi everyone. Welcome to my YouTube channel. Today we are going to discuss about the topic is electricity. So in this video we are covering entire all the topics, all the concepts. So in depth. So we'll be discussing in this video. Even individual topics video also videos also I made. So you can go and check in my YouTube channel. So then you will get the topics explanation. In this video I am completely explaining no all the concepts I'm covering in this video. Make sure that you are watching until the end of the video. Okay, so the now today you can see the table of content. What are the contents are we are going to discuss. So here you can see first one is anyway electricity. The first point anyway we are going to discuss about electricity only, and next one introduction about electricity. So electric current and circuit. Next one electric potential and potential difference, electrical potential and potential difference. Next one Ohm's law, and next one sixth one is factors on which the resistance of a conductor depends, and the resistance of system of resistors. So they are connected in series combination, and resistors are in parallel combination. Next one, 10th one, heating effect of electric current and practical applications of heating effect of electric current. And next one, electrical power. So these are the points we are discussing in this video. So here electricity. So every home, every industry. So nowadays it's very essential thing is electricity. Without electricity, we can't even survive. So it's very impossible task. So very required necessary energy source nowadays we are utilizing. Okay, so you can see in industries, hospitals, next one homes, everywhere. So we are using electricity. Okay, so in this topic, so we are learning the basic components and how the in a home how we are connecting the electricity, in which combination it is, in the industries how we are using. So what are the benefits of their that combination. And next one by natural phenomena what we are observing. So in homes sometimes we will get a heating effect. No, all the points we will discuss in this okay video. And next one electric current and circuit. So what is electric current? Okay, so normally you see you're considering electric current. So what is electric current? So when the current is passing through the circuit, so the electric current I equal to Q by T. So what is I? Charge passing per unit time. So if you take the positive charge or negative charge, so positive charge is moving inside of the conductor. So normally you take the circuit. So one conductor I am considering, this a conductor like this, and you can see the so it's circuit I am considering, this a circuit. Okay, so I'm considering the circuit here like this, or you can take the bulb also here. So here you can consider bulb, or you can take any conductor also. I am considering this a conductor. I am assuming this a conductor. So here if you take this a battery, and battery you consider, we will discuss these components in depth in the coming video. So means in this video online. So next topic. So here you can see, okay, current is passing through it. So if the current is passing inside of the wire, so I equal to Q by T. So what is I? The current. Current is flowing inside of the wire. So Q is nothing but charge. Q is nothing but charge. So what is the SI unit of current? Ampere. So what is the SI unit of current? Current is ampere. So SI unit of charge is coulomb. SI unit of charge is coulomb, and SI unit of time is second. SI unit of time is second. So current is nothing but charge per unit time. The rate of flow of charge. The rate of flow of charge. Okay, so is known as electric current, or charge flowing per unit time. Charge flowing per unit time. The rate of flow of charge. The rate of flow of charge is known as electric current. I equal to Q by T. So what is the SI unit of current? Ampere. What is the SI unit of charge? Coulomb. What is the SI unit of time? Second. Okay. So what is electric circuit? A continuous and closed path of an electric current is known as electric circuit. Electric circuit. A continuous closed path of an electric current is known as electric circuit. So here you can see this diagram. So this is the electric circuit diagram. So the switch, if it is there, the dot is there, means it's a closed circuit. If the dot is not there, this dot is not there, it is open circuit. If the dot is connecting the entire circuit, okay. So here that is a switch, okay. If the dot is there, it is closed one. If it is dot is not there, it is open switch. So a continuous and closed path of an electric current is known as electric circuit. So this is a electric circuit. Electric circuit. Okay. So that is the first one. And the next one, coming to the electrical potential and potential difference. What is the electrical potential and potential difference? Electrical potential is nothing but the work done to bring unit positive charge from infinity to the required field. From infinity to the required field. Okay. So the work done to bring unit positive charge from infinity to the required field. So that is nothing but electrical potential. So you can see here V equal to W by Q. So W is the work done. So work, okay, work is done, work done to bring. So charge, to bring unit charge, okay, unit positive charge from infinity to the required field. So I am taking this infinity. So I am considering the this point infinity. So this is a required field, okay. So I am considering the required field. So if you take this required field, so what happens? So I'm to bring the unit positive charge from this point. So that will be considered as the electrical potential. So coming to the potential difference. What is the potential difference? The work done to bring unit positive charge from one point to another point within the conductor. From one point to another point within the conductor is known as potential difference. So the formula, everything will be same. Everything will be the same. So what is the change in it? The change is electrical potential. In electrical potential, so charge is coming from infinity to the required field. Means we are doing work somewhere to bring unit positive charge from infinity to the required field. That is electrical potential. Potential difference is nothing but the work done to bring from one point to another point within the conductor. So that is called potential difference. So V equal to W by Q. So what is the SI unit of potential difference? Then is nothing but volt. What is the SI unit of work done? Joule. What is the SI unit of charge? Coulomb, as we discussed in the previous topic. Okay. So that is about the electrical potential and potential difference. Coming to the Ohm's law is very important. Even in the exam point of view also, this topic is very important. Why means, so Ohm's law activities they will give in exam, activity based question. So based on this activity, I detailed I explain very clearly in depth concept, in depth of the activity I explain in my video. So you can watch my another video. So you can type Ohm's law activity in my channel, then you will get that. Okay. So Ohm's law, so very clearly I explain. So in this also I'll explain. So here you can see I am taking a 0. Normally you can see 1.5 okay volts of each cell. So how many cells we are taking? 4 cells we are taking. 4 cells. So 4 cells you have to take, and nichrome wire you have to consider. Nichrome wire is a resistor. Okay, it acts as a resistor, you can consider. So I am taking the nichrome wire. Here I am considering the nichrome wire, and that will be connected. So here I am taking the ammeter, and I am considering the okay. So here I am considering the cell. So 1.5 volts, 1.5 volts. So 4 cells. So 1, 2, 3, 4. So 4 cells I have considered. Okay. So we have to consider the 4 cells, and those 4 cells, that 4 cells we are connecting, right? Yes. So thus we are connecting. Next, we can take here. Actually, we have to consider like this. I'm considering this circuit. Here, potential difference. I'm considering potential difference. Here, I'm considering. So we can consider the key also. Here, one more. You can take the key. Key you can consider here. You can consider here. Then you are taking the wire here like this. Yes, I'm considering here. Okay, so this circuit wire I'm taking. Then what happens? So here a potential positive, and here I'm considering like this. Okay, so in this, if you consider here, I'm taking like this side. So yes, so here potential difference, that is nothing but voltmeter I consider. This resistor, this nichrome wire. I'm considering here what is this one, nichrome wire. This a nichrome wire. Nichrome wire. Here 1.5 volts, 1.5 volts like that. 4 cells are there. So in each one you have to connect like this. First you have to you have to connect one cell first. You have to connect one cell first and take the ammeter reading. Ammeter reading, that is nothing but current reading, and so current is passing like this. Okay. After that, voltmeter reading you have to consider. First to connect one cell. So step 1 is first to connect one cell and take the reading of ammeter and voltmeter. Then connect second 2 cells and take the ammeter reading and voltmeter reading. Then next one take connect 3 cells and take the ammeter reading and voltmeter reading. Then take consider 4 cells and take the ammeter reading and voltmeter reading. And so all the readings you take, and you can draw a tabular form. You can draw a tabular form. In this tabular form, serial number, and next one number of cells used, ammeter reading and voltmeter reading. So here you can consider here serial number and number of cells used, and next one ammeter reading current and voltmeter reading, and V by I ratio. So V by I ratio we are considering, V by I ratio. So here the concept is, what exactly the final concept is, the potential difference across the resistor, across the nichrome wire, across the conductor is directly proportional to current flowing through it at the at constant temperature. So the potential difference across the ends of the given metallic wire is directly proportional to current flowing through it at constant temperature. So that is nothing but Ohm's law. So V is directly proportional to V equal to IR. V equal to IR. So very important. So make sure that you are learning. So after table, next one you can draw the graph. The graph will appear straight line. So take on x-axis current, on y-axis potential difference. You can draw the graph. The graph appears linear. The graph appears linear starting from origin. So this is about exactly Ohm's law. Okay. So V is directly proportional to V equal to IR at constant temperature. So that is about Ohm's law. Coming to the next one, factors on which resistance of a conductor depends. So what are the factors? The resistance of the conductor depends. So R is the resistance. So previously V is directly proportional to I. V equal to IR, I said no. R is the resistance. R is the, so here in this case I explained here. So here R is the resistance. R is the resistance. R is the resistance, and I is the current, and V is the potential difference. R is the proportionality constant. So here I will explain so in depth. That's the reason I didn't explain there. So here R is a resistor. Okay, resistor. So resistor is a device which is used to oppose the electric current in the circuit. Okay, resistance is there. Resistance is the phenomena of opposing the electric current in the circuit. So resistance is the phenomena, resistor is the device. What is the SI unit of resistance? Ohm. OHM. SI unit of resistance is ohm. Symbol is this one. Okay. So this is a symbol and SI unit of resistance is ohm. So R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section of the conductor. R equal to rho into L by A. Rho into L by A. Rho is the proportionality constant. Proportionality constant. So here R depends on length of the conductor. R depends on area of the conductor. R depends on nature of the conductor, and R depends on temperature too. R depends on temperature too. What is the resistance? Resistance. Okay. So R is the resistance. So resistance is depends on length of the conductor, resistance depends on area of the conductor, and resistance depends on nature of the conductor, and resistance depends on temperature of the conductor also. So R equal to rho into L by A. Rho equal to RA by L. RA by L. So what is rho? Rho is the resistivity. Rho is the resistivity. Rho is the resistivity. Okay. Resistivity. Rho is the resistivity. Rho is nothing but resistivity is equal to resistance of a conductor per unit length of unit cross sectional area, or you can say resistivity is equal to resistance of a conductor of unit length of unit cross sectional area. So that is nothing but resistivity. That is nothing but resistivity. Rho equal to, so ohm meter square. SI unit of area is meter square. So SI unit of area is meter square, and SI unit of length is meter, and SI unit of resistance is ohm. That is nothing but OHM. So if you draw like this, and this will cancel, rho equal to ohm meter, or simply you can write ohm meter. So this is about the resistivity SI unit. Resistivity SI unit. Sometimes this they will ask in the exam also. Make sure that this derivation, especially this derivation, they will ask 2 marks. So these factors they will ask 3 marks in the exam. So make sure that you are learning all this. Yes. Resistance of system of resistors. Normally you see, you can take one resistor like this, this resistor 1, starting point and ending point I am considering, and one more resistor I have considered. So this also starting point, and this will be the ending point, like R2 you have considered. So this starting point and ending point. So if you connect, so ending point of the first resistor to starting point of the second resistor, then it will be considered as a series combination. And whereas parallel combination, you see, I am taking the starting point, all starting point of the resistors. So I am taking 1 and 2 I have considered like this. This is 2, and I am taking 3 also. This is 3. All starting point of 3 resistors, at one point, and all ending point of 3 resistors are connected in another point. That will be considered as the parallel combination. So these are the system of resistors, like resistors are in series, resistors are in parallel combination. Okay. So now we will discuss in depth about series and parallel combination. This is a series combination, and second one is a parallel combination. So first one is the series, and the second one is the parallel combination. Series and parallel combination. Okay. So next one you can see resistors are in series combination. So now you can consider, I am taking 3 resistors, like 1 and 2 and 3 I'm consider. So here I'm taking the ammeter here. Ammeter I'm considering, that will be considered to the battery. So here it is battery I have considered, like a number of cells are connected. Then you can take switch like that I'm considering here. Okay, so this is a closed switch. Current is passing from positive terminal to negative terminal. So here it is the condition. So we are considering the potential difference, that is the voltmeter across the resistor 1. Okay, so this is the R1 and here it is V1 and R2 and here it is R3. So potential difference across V2, like R2 is V2 and R3 is V3. R3 is V3. Current is passing through it. Current is passing through it. So according to Ohm's law, what is Ohm's law? V is V equal to IR. V equal to IR. In each resistor, you can see entire the circuit. So current is same. Current is same, right? Current is same. Entire the resistors, entire the circuit also. Entire the circuit also, current is same. You can see resistor 1 current is passing, resistor also current is passing, resistor 3 also current is passing. So enter the circuit, the overall current will be the same, but potential difference for each resistor is different. Potential difference, so for each resistor is different. Okay, so then we can consider, so here this series combination. So series combination we can consider, 1 minute I will explain. Here you see resistors in series combination. I'm considering resistors. Here you can take resistors, resistor 1, resistor 1 and resistor 2 like this, and resistor 3 I have considered like this. I'm considering, yes, right. So that will be connected to the circuit, like ammeter I'm considering here. Yes, then it will be connected to the battery. So battery I consider like this. So here I'm considering the battery and that will be connected to switch. Here you can take yes, right. So current is passing through it from positive terminal to negative terminal. Current is passing. This is a positive terminal, this is a negative terminal. Okay, then so here I'm considering this R1 and R2 and R3. So across the resistor 1 R1, across it we have potential difference V1, and across V2, across R2 we have potential difference V2, across R2 V2 we have, and across R3, so V3 we have, okay. So this about resistors in series combination. So entire the circuit current is same. So from Ohm's law, V equal to IR. So we can take a V equivalent. So V effective. So sorry, V effective. We can take V effective. Okay. So V effective or V in series. Okay, potential difference in series. So these three we can consider in different books. They have considered V effective, V equivalent and V series. So I'm considering V as, so it will be convenient to me. So that's the reason I consider. You can take remaining also V effective, V equivalent also we can consider. So V is equal to I into RS. Okay. So resistor 1 you can take, resistor 1 we can take. So V1 equal to IR1. Okay. So R2 equal to, so V2 equal to IR2. And R3, if you take resistor 3, you can consider resistor 3. Yes. So yes, I am taking resistor 3, right? Yes. 1 minute. Okay. Yes. That is nothing but R3 equal to V3 equal to IR3. Okay. So we can consider Vs equal to overall potential difference equal to V1 plus V2 plus V3. So that is nothing but IRs equal to IR1 plus IR2 plus IR3. So I we can take common. I you can consider common. IRs equal to I you can consider common R1 plus R2 plus R3, R1 plus R2 plus R3, I3. So I can get cancel. Then RS equal to R1 plus R2 plus R3. So the effective resistance in series combination is equal to sum of the individual resistors resistance. Okay. So this is about the resistors are in series combination. Resistors are in series combination. R is equal to R1 plus R2 plus R3. And coming to the resistors are in parallel combination. So we are connecting resistors in parallel combination. I am taking one resistor. Okay. And I am considering another resistor like this. And I am taking another resistor here. Yes. So that will be connected ammeter here and like here, and considering the battery. Yes, battery I can consider like this, and you can take the switch and you can consider like this here, positive terminal, negative terminal, current is passing through it. So here it is R1 and R2 and R3. So but when current comes here, some division will be there, I1 and I2 and I3. So current is dividing here, current is dividing. Then from Ohm's law, V equal to IR, V equal to IR. Okay, from that, so current is dividing, no, potential difference will be the same, entire the circuit you can take. So potential difference, whatever it is there, that potential difference will be the same. So then I equal to V by R, V by R. Then that is about IP. So I parallel combination V by RP, because potential difference same. That is the reason I am taking I and R. So parallel combination. So like that resistor 1. So we can write R1. We can write okay, I1 equal to V by R1. So R2 you can consider I2 equal to V by R2, and R3 you can consider I3 equal to V by R3. So then you can take IP equal to, so current in under the parallel combination you can take I1 plus I2 plus I3, I1 plus I2 plus I3. Okay. Then so we can substitute V by RP equal to V by R1 plus V by R2 plus V by R3, V by R3. So we can take V common, right? So from this equation we can take V common, V by RP equal to, we can consider 1 by R1 plus 1 by R2 plus 1 by R3, 1 by R3. So then VB get cancelled. So 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is about resistors are in parallel combination. Resistors are in parallel combination. Clear? Yes. Yes, heating effect of electric current. When the energy source is passing inside of the conductor, is entirely converted or dissipated in the form of heat, is known as heating effect of electric current. Means So the electrons are moving inside of the conductor. So the completely the current will be converted into in the form of heat. So that is nothing but the work done to flow the charge. Okay, so to the flow the charge is nothing but the potential difference into charge. Potential difference into charge. The work input is given to the electrical circuit. That is nothing but in a particular time. That is nothing but the power given to the circuit. The power given to the uh, conductor we can consider. So that is nothing but P equal to VQ by T. So that is nothing but V into Q by T. So Q by T, you know, that is nothing but current. So P equal to VI. So that is the power input is given to the conductor. Then the power is given, the energy source is given to the circuit for unit time. That is nothing but heat is generated in the conductor. So that is nothing but P into T. So that is nothing but VIT. So the heat is generated in the conductor is nothing but H equal to VIT. So V equal to, we know IR we can consider V equal to I into R into I into T. So then we can write I square RT. The heat generated in the conductor is directly proportional to square of current, is directly proportional to resistance, is directly proportional to time. So that is nothing but heating effect of electric current. So the source of energy continuously dissipated entirely in the form of heat is known as heating effect of electric current. Whatever the current is given to the conductor is completely converted into in the form of heat, that is known as heating effect of electric current. Next one, so what are the practical applications of heating effect of electric current? What are the practical applications? So normally you can take, you can see the bulb filament. Tungsten we are using tungsten. Okay, tungsten. So tungsten is the best example. The melting point of tungsten is 3380 degrees centigrade. At the temperature, so until the temperature filament doesn't melt, so at the temperature, so it is very huge. So that is the reason if at that time, at the temperature, so there it will be converting into so heat, then it will be giving light, and it will be giving light. So here you can see the electrical oven, electrical kettle, okay, electrical iron. So these are all examples for the heating effect of electric current, practical applications of heating effect of electric current. So this will be example we can consider in the daily life. Normally, you can see in homes, in household surface, 5 ampere of so current will be using. 5 ampere in industries, the range will be increasing in a practical applications. So 5 to 15, 5 to 20 also. So the current range will be utilizing in industries. Okay, so that is a practical applications of current. And next one, coming to the electrical power. So the electrical power is given to that okay, so conductor P equal to, previously we discussed, P equal to VI. So that is nothing but V equal to IR we can consider, then P equal to I into R, then I you can consider, then I square R you can take. So then we can consider, instead of I we can take V by R also, then you substitute, then one more formula you will get, that is nothing but V into V by R. So you can consider V equal to P equal to V square by R. So these are the formulas. This is about the electrical power. So that is nothing but same on the heat energy given entire the circuit. Okay. So the total energy will be completely converted in the form of heat. Okay. That is a energy input is given to the circuit, to the conductor, then the heat will be generated. Okay, so then we can consider okay, 1 kilowatt hour equal to 1 kilowatt hour equal to 3.6 into 10 power 6 joules, 10 power 6 joules. Suppose you can take 1 kilowatt hour, nothing but 1000 watts, into 1 hour equal to 3600 seconds. 3600 seconds you can consider. Then you can take 3 here, and so 36 into 10 power 5 watt second. That is nothing but we can take 3.6 into 10 power 6 joules. So that is the answer. 1 kilowatt hour equal to 3.6 into 10 power 6 joules. Watt second we can write, or simply joules also we can take. So this is about the electrical power completely. I hope so you got to know. Then so previously all the points what we discussed, resistor, submeter, and next one table of contents. Okay, so I hope you you know all the points about electricity in one short video. Thank you so much. So if you want more videos like this, so please like, share, subscribe. Thank you so much.